Ready for launch. FTS.
FTS go.
Props go. AVI.
AVI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello and welcome to SpaceX's live coverage of the BlueBird 11-13 mission for AST SpaceMobile. SpaceX's Falcon 9 rocket is currently awaiting liftoff from Space Launch Complex 40 at Cape Canaveral Space Force Station, with launch scheduled for 3:49 a.m. Eastern Time. Hello everyone, my name is Amanda Years and I'm a ground systems engineer here at SpaceX. Thank you for joining us. Today, SpaceX's Falcon 9 will be delivering 3 satellites to a low Earth orbit, BlueBird 11, 12, and 13. Falcon 9 previously launched AST SpaceMobile's first 5 commercial satellites, BlueBird 1 to 5 in September 2024, and BlueBird 8, 9, and 10 in June this year. This will be SpaceX's 92nd Falcon launch of the year. Teams have been monitoring weather conditions near the launch pad today, and we are currently tracking a 25% possibility of launch weather violation due to a detached anvil cloud, which is a potential fly-through risk. If for any reason teams need to stand down from launch, a backup opportunity is available tomorrow, August 6th at 3:21 a.m. Eastern Time. Additionally, due to the layout of the payload adapter for this mission, views of the payload will be obstructed. So we'll be ending our live webcast after Stage 1 landing, and we will confirm the deploy on X. BlueBird 11, 12, and 13 are part of AST SpaceMobile's next-generation satellites designed to support mobile broadband connectivity. While the countdown continues, let's hear more from AST SpaceMobile.
AST SpaceMobile's BlueBird satellites are unlike anything in orbit today. They're not just satellites, they're cell towers in space. Designed to connect to today's existing smartphones and deliver 4G and 5G broadband. No updates, no special hardware required. The challenge is smartphones have tiny antennas. To connect them from space, we need something massive. AST SpaceMobile's next-generation BlueBirds are the largest commercial phased arrays ever deployed into low Earth orbit. These enormous arrays allow each satellite to form hundreds of precise communication beams at once, with peak data rates of nearly 200 megabits per second. Enough for millions of calls, streams, downloads, and texts every day. Recently, we achieved a peak download speed of 98.9 megabits per second using our Block 1 BlueBirds in international waters. These satellites are manufactured with 95% vertical integration across over 500,000 square feet of state-of-the-art facilities across the U.S. and beyond. We have partnered with nearly 60 leading mobile network operators worldwide, including AT&T and Verizon in the U.S., Bell and Telus in Canada, Vodafone in Europe, Rakuten in Japan, and STC Group in the Middle East and Africa. And we have the support of Google and American Tower as strategic partners. AST SpaceMobile is making global cellular broadband possible for the first time. With our imminent launch and ground production advancing through BlueBird 42, we will soon fulfill our mission to connect the unconnected.
The Falcon 9 rocket supporting today's mission is a 2-stage rocket designed for the reliable and safe transportation of satellites, cargo, and people. Starting from the very top of the rocket is the payload fairing. The fairing is a protective shell that shields the payload from aerodynamic heating until the vehicle is outside of Earth's atmosphere. The shape of the fairing contributes to Falcon 9's overall efficiency, and it helps to reduce drag during flight. Once in space, the two fairing halves will separate and fall back to Earth, where they will be retrieved by a SpaceX recovery vessel to be refurbished and reused on future flights. Both halves of this fairing are flight-proven, with one side flying for its 32nd time and the other for its 18th. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again.
Stage 1 RP1 load complete.
Great news, propellant load is ongoing, RP1 complete on that first stage. Right below the fairing is Falcon 9's second stage, which features a single Merlin vacuum or MVAC engine. And below the second stage is the black carbon fiber interstage, which houses the MVAC engine. Below that is the first stage, or booster, which will be fully loaded with about 1 million pounds of liquid oxygen and RP1 over the next few minutes. The first stage makes up the bottom 2/3 of the vehicle, and it has 9 Merlin M1D engines at the bottom, which generate more than 1.7 million pounds of thrust. The booster supporting today's mission will be making its 30th flight today. It previously launched NASA's Crew 5, GPS-3 Space Vehicle 6, Inmarsat I-6F2, CRS-28, Intelsat G37, NG-20 TD-7, BlueBird 810, and 21 Starlink missions. Looking ahead about 2.5 minutes into flight, the first stage will separate and make its way back to Earth. Today, the booster is headed to SpaceX's drone ship, a shortfall of Gravitas, currently stationed in the Atlantic Ocean. With about 5 minutes to go, everything continues to look on track for launch.
Falcon 9 tanks are pressurizing for strong back retract.
Now, as you just heard, coming up next in the countdown, the Transporter Erector, or TE, will begin to retract away from Falcon 9. There's 2 main steps in this sequence. First, the clamp arms around the second stage will open to clear the way for retract. Then the TE will begin to pivot backwards and slowly move away from the rocket.
Strong back retract has started.
At this point, those clamp arms around the second stage will begin to clear the way for retraction. And these clamps are used to stabilize the second stage during propellant loading, as well as to reduce movement in high wind conditions. Once these clamp arms are fully open, the TE will begin to pivot back, and Falcon 9 will be fully free at the top. Now you can see those clamp arms are free and clear of stage 2. Now the TE plays a very active role in the launch process. It rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds prior to liftoff. It also provides fuel, power, telemetry, and command connections between the ground systems and the rocket. If you look carefully, you can see that TE slowly reclining away from Falcon 9. Now we're coming up on one of our propellant loading milestones, which will be the completion of liquid oxygen loading on the first stage.
Stage 1 LOX load complete.
Right on schedule, and the second stage will wrap up liquid oxygen loading in just under a minute from now. In addition to RP1 and liquid oxygen, cryogenic helium is also loaded onto Falcon 9. Falcon 9's tanks are pressurized using helium, and that helium is also chilled to remain compatible with the cryogenic plumbing on the vehicle. During flight, the pressurization from the helium helps to force propellant into the engines as the tanks empty. In these last few minutes, Falcon 9 is performing final health checks on primary communications, avionics, and propulsion systems, and we're coming up on that final milestone in prop load of liquid oxygen loading on stage 2.
Stage 2 LOX load complete.
And with that confirmation, Falcon 9 is now fully loaded with 1 million pounds of RP1 and liquid oxygen. You'll notice white clouds venting around the rocket, and that isn't smoke, it's condensation. It comes from the liquid oxygen
Ground gas closeouts.
boils off in the propellant tanks, and as it gets vented overboard to maintain pressure, it forms these visible clouds. Gas closeouts are underway, which involves topping off tanks and sealing vents to maintain pressure. At this point, we're standing by for confirmation that Falcon 9 enters startup.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the count, and both stages will pressurize for launch. We're now waiting to hear from the launch director for the final go.
This is the LD. Go for launch.
Great news there. LD is go for launch. So let's sit back and watch as Falcon 9 prepares for a liftoff.
T minus 30 seconds. T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon and go BlueBird.
Plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. The vehicle is currently preparing to throttle down in preparation for max Q, which is the point
Power
of
and telemetry nominal.
maximum aerodynamic stress on the vehicle. Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Vehicle is supersonic.
Max Q is coming up in just about 10 seconds.
Max Q.
And there's confirmation of max Q. The Merlin engines are now going to throttle back up to full power now that Falcon 9 is out of the throttle bucket. And from here on, even though velocity will be increasing, the atmospheric density is decreasing, which results in overall less loads on the vehicle.
And back chill.
There are several events coming up in quick succession, starting with MECO, stage separation, and then second engine start 1, or SES1. Main engine cutoff, or MECO, is when all 9 M1D engines will shut off to slow down the vehicle in preparation for stage separation, when the first and second stages decouple from one another. This will be followed by the MVAC engine on stage 2 igniting, which is called out as second engine start 1, or SES1. That first MVAC engine burn will last several minutes to propel the second stage and the attached payloads to the desired orbit. After that, the fairing will jettison from the second stage as it's no longer needed to protect the payload once Falcon 9 is in space. So we should be hearing that sequence of events in about 5 seconds.
Main engine cutoff.
Stage separation confirmed.
And back startup.
And there we had confirmation of those 3 events that happened back to back. Again, that was main engine cutoff, stage separation, and second engine start 1. Coming up next in about 20 seconds will be fairing separation. Falcon 9 will jettison these payload fairing halves since they are no longer needed in the vacuum of space, and SpaceX teams will attempt to retrieve them when they fall back to Earth.
Fairing separation confirmed.
Great news, successful fairing separation. Those fairings will now make their way back to Earth for recovery. The next major milestone coming up will be entry burn on Falcon 9's first stage, and that's scheduled to occur around the T+6 minute and 23 second mark. The entry burn will be used to slow the first stage down as it heads towards SpaceX's drone ship, a shortfall of gravitas located in the Atlantic Ocean. Without this upcoming entry burn, Falcon 9 would only be using atmospheric drag to slow down, and this would add extra stress to the vehicle. Slowing down the booster reduces re-entry forces, which then allows SpaceX to recover and reuse that first stage. As we approach the entry burn, be sure to keep an eye on the booster engine graphics that will appear on the lower corner of the screen. That will display the arrangement of the 9 M1D engines, as well as the active feedback of their ignition. Looking ahead, following the upcoming entry burn, the booster will initiate a landing burn, which will slow the vehicle down even further for a precise touchdown on our drone ship. We still have more than 1 minute to go until the beginning of entry burn. The first stage is not only using the Merlin engines for the re-entry and landing process, it also uses its titanium grid fins and nitrogen gas thrusters for stability and control. Falcon 9 is equipped with 4 hypersonic grid fins, and those are positioned near the top of the first stage. The Falcon 9 booster supporting this mission is flying for its 30th time. It previously supported NASA's Crew 5, GPS-3 Space Vehicle 6, Inmarsat I-6F2, CRS-28, Intelsat G37, NG-20, TD-7, BlueBird 810, and 21 Starlink missions. We are just moments away from the beginning of the entry burn.
Stage 1 FTS is saved.
Stage 1 entry burn startup.
The entry burn has started up on the Falcon 9 first stage booster, and this will last about 30 seconds. Again, the purpose here is to slow the vehicle down in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And that concludes the entry burn. As mentioned earlier, we will be attempting to recover this booster with SpaceX's drone ship, a shortfall of gravitas, currently stationed in the Atlantic Ocean. The next milestone, coming up in about 1 minute, will be the Stage 1 landing burn. As that landing burn happens, you'll notice a drastic decrease in the speed and altitude of the vehicle. The Merlin engines performing the entry and landing burns on Falcon's first stage are optimized for sea level performance, and they each achieve about 190,000 pounds of thrust during ascent and descent. In comparison, the single MVAC engine on the second stage, which you can see is still undergoing
Stage 1 transonic.
that first burn, produces 220,500 pounds of thrust in a vacuum environment.
Stage 2 terminal guidance.
Now that landing burn is coming up in about 15 seconds from now. This will be Falcon 9 slowing down the remaining speed needed for a gentle and precise landing. Keep an eye out for landing leg deploy just
Stage
prior
2 FTS is safe.
to touchdown.
Stage 1 landing burn.
Landing burn has started up on the first stage.
Stage 1 landing leg deploy.
Stage 2 shutdown.
Stage 1 landing confirmed.
And there we had another successful first stage landing for this flight proven booster. This was its 30th landing. We also
Nominal orbit
heard
insertion.
great confirmation of SECO-1 and nominal orbital insertion. As mentioned earlier, due to the layout of the payload adapter for this mission, views of the payload are obstructed, so that will bring us to the end of today's mission coverage. Keep an eye out for confirmation of payload deploy on X. We would like to thank AST Space Mobile for once again entrusting SpaceX with their satellites today. We'd also like to thank the FAA and the Eastern Range for their support of today's mission. Be sure to check out spacex.com/launches for the most up-to-date information on upcoming launches, and follow SpaceX on X for ongoing updates. We'll see you next time.